So the meaning of your work is we are 99% confident that the true mean, or you can just copy down all first year students everything, so you can just copy everything, that the true mean is expected to fall between, oh, here it is, I have already written, yeah, is expected to fall between, expected to fall between those two numbers, those two numbers. So that is the meaning of your work. Okay. Okay, here it is. I have written that. Why would I write it again? It's already here. Interpretation. So I have drawn the diagram and I have also written the interpretation. I'm sorry, I did not see that. Maybe I have to make the screen bigger. Everything is here. So that is the work or the meaning of the work that you are doing. You can read it. Okay, so I am putting the diagram. The diagram is going to have the center 137. On either side, I'm going to have the margin of error. And the margin of error is going to give me the cutoff point, lower limit, and another cutoff point, which is the upper limit. So the meaning, or you can say the interpretation of your work is, we are 99% confident that the mean study time for all the first year students in that college is expected to fall between those two numbers. Okay, all right. Take away TI and then go to stat. Go to calc. And this time move on to test. Select option number 7, which is Z interval. So go to stat, move on to calc, and then move on to test. Select option number 7, Z interval. So you will get the input screen with the two options, data and stats. So I'm going to be choosing the stats option because I'm given all the numbers. I'm not given the data for 269 students, but I'm given the mean of the data, which is 137 minutes, right? So I'm going to be choosing the stats. If I'm given the data or the real observation for 269 students, then I'll be choosing the data, but the data is not given. I'm given only the mean of the sample, 269, which is 137. So now I want you to plug in all the numbers that you are given in your problem. See what happens. And plug in your sigma value, which is 65, plug in the X bar value, plug in N, plug in C level, and then hit calculate. And then you get the output screen. Are you all getting this? Is that correct?
Yeah, I got that same thing.
Yeah, so please use your calculator because chapter 14 and chapter 19, for every single chapter, chapter 11, 13, 19, 14, everything, the answer is here. Okay? So check, plug in the numbers, you will get the answer. All right? But make sure you remember option 7. All right. So the next one, that's it. This is the first part of chapter 14. You are going to find the probable limits for mu. That's it. That's it. We already finished first half of chapter 14. All right. So the next problem is again, if you read the question, you are given some information. So the population the population standard deviation is given to be 0.79. And if you read the question, you are given the sample size is 148, and then the average coming from the sample of 148 is 5.91. So again, dating the problem is very, very important. You need to see where the numbers are coming from. The numbers could come from the population, the numbers could come from your sample. If the numbers are coming from the population, we call that as the parameter. If the numbers are coming from the sample, the numerical value is coming from the sample, then it's called as statistic. Remember that, okay? All right. So with the given number sigma, n, and x bar, you're going to find the 99% confidence limits. Um, Diagram is important. So you will not go wrong if you draw the diagram, or I want you to understand the meaning of the work that we are doing now. We are finding the lower limit, we are finding the upper limit, which is going to be the plus or minus, or you can say the margin of error. Okay. So just go over that. All right. So now what I'm going to do here in the B part, I'm going to reduce my confidence level to 90%. Instead of a 99%, my confidence level this time is going to be 90%. I guess you are all remembering, so I'm not spending my time in explaining those because I have written a very clear key for a subdivision. You can always check, and the interpretation is also written there, okay? Now I'm moving on to the B subdivision where the C level, I am changing it to 90%. So from 99%, I'm reducing my C level to 90% with the same numbers. So what happens here? You are going to see when the sea level drops, when the sea level goes down from 99% to 90%, obviously the margin of error is going to be shrinking. Why? Because your multiplier is no longer 2.57 that you used in 99%. In 99%, the multiplier, or you can call that as the Z star value, which is 2.576. Whereas in 90%, that number is shrinking, and that's going to be 1.645. The confidence level as a 90%, the Z star value is going to be 1.645. So because of that, then the confidence level is going down. From 90% to 90%, you will notice that the margin of error is also going to be shrinking, and as a consequence, that the confidence interval is also going to be shrinking. So I would like to mention here the result as C goes down, the margin of error shrinks, and as a result, your confidence level is going to be shrinking. Okay, all right. So that is one result that we have seen. All right. The next question is the noise level at various urban hospitals. Yes, so the mean is given and the mean of 84 corridors. So the sample size is n is 84, and then the mean is not known. That's what you are going to be calculating. And your standard deviation is given to be 7.9, and that is the number coming from the population. That is 7.9, and you have to find with the C level of a 95%, get the confidence limits for the true mean, which is mu. So the C level 95% is going to give you the critical value, which is plus or minus 1.96, and then X bar, the number coming from the sample of 84 corridors is 61.2. That number is given in your problem. The noise level is measured by decibels. So that is given, and then your sigma is given. Mean and standard deviation, they both will have the same unit of measurement, right? The X bar and the standard deviation both will have the same unit of measurement. So that is also given in decibel. And then your n is given, check, plug it in, and you get your lower limit and the upper limit. So again, I have written how to use the TI to get the numbers. So go to stat, move on to calc, and then move on to test. Select option number 7, plug in the numbers. Again, for 84 corridors, you are not given the sample data, so you better go with the stats. It is asking what is the value of sigma, X bar, n, and then the C level. Check all 4 numbers you are going to plug it in, and then hit calculate. boom, you get your lower limit and the upper limit. So for chapter 14, for finding the confidence limit, you can cheat me. You can use option number 7 in stat calc, and then to test option number 7. All right, so you can move on to the next problem. Everything is pretty simple. So you can see how to get the 80% confidence limits. You can also learn how to use your calculator to get the math by hand. You just plug in the values and simplify, get the values, make sure that matches with your PI answer. Okay. So if you have any question, you can check with me. Otherwise, I'm just going to show you one by one. That's it. There is nothing here. It's pretty simple. You are going to be given all 4 numbers that you are looking for. The sample size will be there, X bar will be there, sigma will be there, and then the C level is going to be there. All right. So one result that we have seen is if we are going to be shrinking the confidence level, that means your margin of error goes down, and as a result, your confidence interval is going to be shrinking. That is the result that we have seen. And the vice versa, the other way, if you are going to be increasing the C level, obviously the other way, the margin of error is going to be expanding, and as a result, your confidence interval is going to be enlarged. Okay. All right. Are you all with me? Shall we move on to the next question? Number
With
5.
you.
Wonderful. How about others? Are you all with me? Anybody has any question? Good. All right. Super good. Super good. It's pretty simple. You can do that. I have 100% confidence on you. No, not 90%. I'm 100% confident on you. You can do that. Okay. So the next one is going to be the confidence limits for you. But let's focus on the multiple choice question. So, which of the following would produce a confidence interval with a smaller margin of error than the 90% confidence interval you computed above? Okay. So there are 4 options given, and the option 1 says give the drug to 25 subjects rather than 100 subjects. So my criteria is to have a smaller margin of error. Okay. In order to have a smaller margin of error, out of the 4 sentences given, I need to pick the correct one. What is my goal? To have a smaller margin of error. We do not want a larger margin of error. My goal is to have a smaller margin of error. Okay. Out of the 4 sentences, I need to pick the correct one. All right. So the first one says, instead give only to 25 subjects rather than 100, since 25 people are easier to manage and control. But what happens here, as the sample size n goes down, your margin of error is going to be increasing, right? Only when the n is increasing the margin of error, because you are going to have sigma over square root of n. So when n increases, your sigma over square root of n is going to go down. When the denominator gets bigger and bigger, your sigma over square root of n goes down. On the flip side, when you are going to be decreasing your sample size, your sigma over square root of n, it's going to be the other way. The variability increases, right? So that's why I'm not going to be getting variability number is dropping and increasing with the opposite sign of your n, right? So now let's continue to write. How about the margin of error? So the margin of error is also going to be decreasing, because the margin of error is given by z star times sigma over square root of n. So that number is also going to be going down. When n increases, your margin of error decreases. That's right. And the same way, your n is decreasing, your margin of error is going up. So they're all going to be acting in the opposite way. All right. So that's not going to be happening here. The smaller margin of error is not going to be happening if we decrease the sample size. So that is ruled out, that is eliminated. And this next sentence, if we increase the sample size from 100 to 500, obviously as n goes up, your margin of error goes down. So that makes sense. So that is acceptable. And let's see the C sentence. Compute the C level, which is a 99 percentage rather than 90 percentage. So that is also not going to give you smaller margin of error, because larger the confidence level, you are going to have bigger margin of error. So that's not going to give me a smaller margin of error. So that is also ruled out. Why? I have also said that in this problem. As the confidence level increases from 99 percentage, as the confidence level decreases or increases, whatever, when that number is bigger, your margin of error is going to be shrinking or enlarging. One of the two is going to be happening, right? Either way, you can say bigger number to smaller number or smaller number to bigger number. Either way, you can consider that. All right. So with that said, I'm also eliminating option number 3, because remember, I want the smaller margin of error. So the C option is also going to be ignored or eliminated, because increasing the C level will stretch or enlarge my margin of error. I want smaller margin of error. I don't want bigger margin of error. And none of the above is obviously ruled out. So the correct one is, as the sample size increases, your margin of error goes down. That is the correct one. So we have seen two results. One result is, as we increase the C level from 90% to 90%, we get a bigger margin of error. As the sample size n increases, your margin of error is going to be shrinking, and that way the curve is going to be steeper curve. All right. So we do not want to have a bigger margin of error. We want to have a smaller margin of error. So this is all basically depends on the research person's decision. But we are seeing the consequences. What's going to happen? Okay, if we increase the sample size, or if we decrease the sample size, or if we increase the C level, or if we decrease the C level. So these are all the consequences. That's what I'm going to call them as deductions, or the results that we are going to be seeing. All right. So the rest of the problems, some problems, I guess I left it blank, or I just picked only the information given in the problem, and you can plug it into your TI, and you can get the lower limit and the upper limit. All right. So here, let's see the B subdivision. Suppose I had the lifetime of a sample of 100 reds rather than 25, which of the following is correct? So now the question is flipped the other way. Okay, so here you are going to have the margin of error, 95% confidence level would decrease, because you have the fact that as n increases from 25 to 100, the margin of error decreases. Okay, so which one is the correct statement? The correct statement is going to be the margin of error for our 95% confidence interval would decrease. So the same confidence level as the 95, if we increase the sample size, your margin of error will go down. So number 8, number 9, so everything is similar to the previous problems that we did. So I recommend you to pick the 4 numbers given in the problem. N is 50, X bar is given, which is, so you have to read the question. That is very important. Okay, here I can see her. All right. Anybody has any question so far?
Mrs. Bartlett.
Go ahead, Pablo.
Can you explain again how increasing the confidence level will increase the margin of error?
Because your multiplier is different. If for C, which is a 90 percentage, look at the multiplier. The multiplier is, I'm going to the top screen so that I can show you the number. Okay, you see that? It's coming, hang in there. Yeah. For 90 percentage, your number is 1.64, right?
Right.
For 95 percentage, the number gets bigger, which is 1.96.
Got it.
So that way it's going to stretch. For 99 percentage, your number is even bigger, 2.58. So that's going to enlarge your length of the interval. Make sense?
Yeah.
Everything is because of your Z star number.
Yeah. So that will increase the size of the interval, but
It stretches. It stretches.
yeah, it stretches the interval, correct?
Yes, it stretches the interval, or you can say the length of the interval is going to be bigger for 99 percentage as compared to 90 percentage.
Yeah. So if you increase the size of the interval, doesn't that decrease the size of the margin of error?
No, the margin of error is the second component, right? When the multiplier gets bigger, the margin of error is also going to be larger, though.
Okay. Yeah. Now it makes sense. Yep. Okay.
All right.
Thank you.
From the center, the margin of error on either side is going to get enlarged.
Got it. Thank you.
It's coming. Hang in there, it's coming. All right. So again, we have seen two results. Okay, so when n increases, the margin of error goes down. When C level increases, your margin of error stretches. So these are the two results that we have seen, or the vice versa. Okay, all right. Let's see the interpretation of the statement. So you are going to pick the correct statement. I told you the mean or 95% confident that the true mean cholesterol, which is your mu, is expected to fall between the two numbers 175 and 250. So the meaning of the sentence is, this is the appropriate interpretation or the meaning of the sentence. We are 95% confident that the true mean mu, which stands cholesterol level here for this problem, is expected to fall between the bottom number and the top number, and the probability statement is equal to 0.95. So this is like your event. This is like your lower limit, and this is the upper limit. So your mu is expected to fall between those two numbers, and how confident you are, we are about 95%. So we are not talking about the sample, we are talking about the population mean mu. So that's why you are going to eliminate the rest of the options. We always talk about the population mean. So think about your sample is going to be acting like a true representative of the entire population, or based on the single sample data taken from the population, you are going to do the projection for your entire population. So either way, you can say that. But the sample data is used. That is going to be the true representative to do the projection for the entire population. Okay. All right, so I guess again the rest of the problems are based on the same formula. To pay attention to the confidence level you are given in the problem and use the appropriate critical value. And I have also drawn what is the population. So my rectangle is the population. And from that population, I'm picking a sample of n is equal to 72. And the 72 samples is going to give me the mean. That's my sample mean coming from the circle, which is my sample taken from the population. And my sigma is also given, and I'm going to be getting the probable limits for mean. Yeah, check with me if you have any question. Other than that, I have just posted everything in my class notebook, so you can go over that. The diagram is also there, and my population is there. The population is rectangle, and there is a tiny circle inside. That's what I call it as my sample. So I'm just plugging in the numbers in my formula to get the lower boundary and the upper boundary. And again, I have written based on a single sample taken from the population, do the projection for the entire population, because the sample is my true representative of the population. And then the diagram tells you the sea level is a 90%, so you are getting the lower limit and the upper limit. So the lower limit is 123.6 and the upper limit is 128.98. So if you are getting the average of the lower limit and the upper limit, that's also going to be called as your center. In other words, you can say the lower limit plus the upper limit over 2. Lower limit plus the upper limit, because I told you that they are going to be the equidistant number, right? So this is going to give you the center. Because they are equidistant number, this is the positive margin of error and this is the negative margin of error. So they are equidistant number from the center. So when you add these two numbers, you can check that. When you add the lower limit number plus the upper limit number, and then you average it out, you will be getting your center, which is 126.06.
I actually have a question, Mrs. Bala.
Go ahead, Sabala.
So on the TI-84, when you're doing the option number 7, under stat tests, yeah, I'm trying to pull it up right here. Yeah, so so like the two numbers that you calculate on the output screen, after you plug in your standard deviation, X bar, N, and C level, the first number is going to be your lower limit, and then the second is going to be your upper limit, correct? Okay, awesome.
Because they are separated by a comma. Always we read from left to right, right?
Right.
We always read from left to right. So the left number is going to be the lower limit, and the right number is going to be the upper limit.
Awesome. And then in whatever said confidence level that you're talking about.
Exactly.
Okay, thank you.
Remember, in always we read from left to right in math. So PEMDAS is there, right? So the lower limit, comma, the upper limit. That's why I'm telling you, use normal CDF Z1, comma, Z2, because the area starts from left to right. That's what we call it as the cumulative area. The area always begins from left tail to wherever it wants to stop. So that's going to be the cumulative area or the cumulative probability. All right. So yeah, that's about it, I guess. So here it is. I have written twice the margin of error is the big. So the margin of error is always going to be with a plus or minus sign, and twice the margin of error is the width, or width is always going to be associated with the plus or minus sign, or you can call the margin of error is going to be the equidistant number from the center. It is going to be expressed in plus or minus sign. Okay. And the formula is x bar plus or minus z star sigma over square root of n. So that is going to be the formula that's going to be used for finding the confidence limits. If you are just finding the margin of error, the margin of error is going to be just the second component. So in problem number 11, you are given the sigma, you are given the sample of size n is equal to 25, and then the mean score of 25 students is 104.32. So everything is given, and your first part, you are going to find what is the margin of error. So you are not finding the confidence limits in the first part. In the first part, they are asking you what is the margin of error. So I wanted to use the second component of your formula, which is C star sigma over square root of n. So the margin of error is 5.88. And what is that 5.88? That 5.88 is the number that's going to be on either side. So this is going to be the center. On either side of the center, you have margin of error, which is positive 5.88 and negative 5.88. So the lower limit is 98.44. You can always plug it into your TI and you can get that. But I want you to understand what is margin of error, what is the center, what is the width, and what is the interpretation given by your confidence limits. Are you all good?
Yep, I'm good. Thank you.
Yeah. So it's pretty easy. So yeah, so you can try the other problem, and I have also posted some more problems here. You can do that. Okay. So the answers are here. You can try. You can do that. Suppose if you are given the data, when the data is given, with this I'm closing, okay? So when the data is given, I wanted to plug in the data into a TI. Because it's a small data, I did not pick a big data because you may have to enter all the numbers. So instead of your sample mean, they have given the sample data of 3 observations. So the 3 observations are 0.8443, 0.8363, and then 0.8447. So you are going to find 95% confidence limits for you. So you are not given the sample mean. Instead, you are given the sample data. So I have the population, which is my rectangle, and the population standard deviation is given to be 0.0068. All right, the variability is such a minuscule number, and then you need to find the lower limit and the upper limit for the population mean mu or the true mean, and the sample of n is equal to 3 observations is given, and 3 observations are listed, and the sea level is a 95%. So let's work on here. So now this is how we are going to be doing with your TI. When the data is given, I want you to go to stat and then move on to edit. So you are going to plug in the data in any one of the columns. So plug in the data in any one of the columns. Plug in the data in any one of the columns. Any one of the 6 columns. Whichever column is available, because you are given L1, L2, L3, L4, L5, L6, right? So L1, L2, L3, L4, L5, L6. There are 6 columns given in your TI. So plug in your data in any one of the 6 columns. So I used L4, and then once you are done plugging in the data, and then the next thing is go back to stat again, and then this time move on to test, and you will see the change. So I'm going to be choosing the same option number 7, Z interval for mu, and this time I'm not going to be choosing stats. I'm going to be choosing the data option. Okay. So once I pick the data option, the screen changes. See, it's not asking for your X bar, right? It's going to ask the sigma value as always. So the sigma value, plug it in. Maybe you can use the TI and you can check for yourself. Okay, so the sigma values can be 0.0068, and then it's going to ask where is the list or the data stored. In my case, I have it in L4. I don't know where you are going to have the data. So wherever you entered the data, second L4, all right? Because L1, L2, L3, L4 are given in blue color. I want you to plug in the second button first. I want you to hit the second button first and then hit L1, L2, L3, L4, wherever you stored the data. And then the frequency is 1 default, don't touch that. Move the cursor down to sea level, which is 0.95, and then hit calculate. So you will get the output screen. The output screen is output screen. And this is the input screen. Anybody has any question?
I get it. Thank you.
Yeah. How about others? Are you all trying or you all using your calculator? Because everything is on calculator. For chapter 14, chapter 19, everything is on calculator. Are you all good? Are you trying?
Oh, quick question about using data for these for the Z intervals. The frequency is always going to be 1, correct, as a default? Okay.
That's right. Alright, so maybe later today you can sit with this worksheet and then you can have your TI if you are not having your TI with you right now. You can try and make sure you understood how the data option is going to be used when the sample data is given. Okay? Alright, so the rest of the problems I left it blank. I did not do the answer key or I did not write the answer key. You can I posted a lot of problems, so you can just them all right? So in a nutshell, just for 2 minutes, okay? So what we have seen here is going to be overall information on the confidence interval. The confidence interval or confidence limits, okay? So the vocabulary are going to be your confidence level, which is nothing but your probability. And then you have the margin of error. That's a new term, margin of error, which is going to be on either side from the center. And then X bar is an estimate of mu, which is the same as the center. And then the critical values for the desired confidence level C. Desired confidence level C. All these are new vocabulary word to you, okay? C, that's right, the critical value. And then you have the margin of error, and then the formula for confidence limits. C level confidence limits formula. That's right. And then you have to understand what is the interpretation of the confidence limits. All right. And then what is the goal or the objective or the purpose? Goal or objective or purpose of having the confidence limits. Right, and then the formula, which is X bar plus or minus Z star. sigma over square root of n, and then you have where z star is equal to critical value for given c, for given c level. So that critical value table you don't have to memorize because you can use your formula card. If it is the exam given taken in the classroom, usually I will be giving the number. So if it is a 90%, it is plus or minus 1.645. If it is a 95%, the numbers are plus or minus 96. And if it is 99%, it is going to be plus or minus 2.576. Or if it is going to be, say, for example, 98%, so I am going to be working on inverse norm. I'm left with the 2%, so inverse norm 0.01 enter. So if I'm going to be using my calculator, so go to second was option number 3, 0.01. So that number is 2.32637 or approximately plus or minus 2.33. So this is how I'm going to be getting inverse now 0.01 because I'm left with the area 2%, that's going to be given to both ends. Okay, so whatever number is given, you can still get. What is the number for 96%? So the 96% is going to be, again, this number is inverse norm. I'm left with the 4%, so it's going to be 0.02 inverse norm. So this is going to be inverse norm 0.02. The number is going to be negative 2.5. So plus or minus 2.05. So like that, we can just get that. Okay. All right. And then the deductions. So what are the deductions? So we have seen the deductions. So the first one is as n increases, your sigma over square root of n goes down. And then your margin of error, which is equal to z star sigma over square root of n, that is also going down. And then your margin of error goes down, and then as a result, confidence limits are shrinking. Because it's going to be shrinking, it's going to be small. And then the other one, as n decreases, your sigma over square root of n increases, and then your margin of error is also going to be increasing, and as a result, your confidence limits are stretching. Limits get enlarged, or we can say wider. All right, the result number 3 is as sea level increases from 90% to 99 or 95%, margin of error stretches. And as a result, confidence limits they are going to be wider, or it widens the confidence limits, either we can say. As the sea level decreases from 95% to 90%, MOE shrinks, confidence limits shrinks, or it's getting narrower. Right? So avoidance, narrower. So these are all the results that we have seen today about the first part of the material, where you have several new terminology or the vocabulary and the formula, and then the critical value table and the deductions. What happens when the sample size increases or decreases? What happens when the C level increases or decreases? What happens to the confidence interval? What happens to the margin of error and everything? Sounds good?
Yep, that sounds good to me. Thank you.
All right, so tomorrow I'm going to be talking about chapter 15 and then chapter 14 again, okay? So chapter 15 is very simple, so you can just go over the material posted on OneNote, go over that for about 5-10 minutes. I will be talking about how to do these problems given in chapter 15, and then again we are going to be discussing the confidence limits, sorry, not the confidence limits, the testing of hypothesis. Oh, go ahead. I'm sorry.
So for the Z star in the critical values table, do we automatically just round to the 2 decimal points, or will it tell us what we should round to?
Yeah, 2 or 3 decimal. Usually this is the table that we are going to be using, or the instructions will be given in your problem. Yeah, they will give you the instructions in your problem, because the next number is going to be 0 though here. Yeah, for if you do that, the number is going to be close to 0, because you are going to use inverse now 0.025, right? So when you use inverse now 0.025, just see that it's going to be it's going to be 1.95666. So that's why I'm writing it as 1.95966. So approximately. But you will not have a very big difference if you use it as a 2 decimal or 3 decimal. There is going to be tiny difference. It's not going to affect your answer big time. As long as it is 95, use 1.96. If you use 1.95966, answer is still going to be the same. That will not make a huge difference. But usually they will be giving you the instruction, keep the number as 2 decimal or 3 decimal, but otherwise you just stick with these numbers. Okay, stick with these numbers to get the more accurate answer, so that it will match with your sapling learning answer. Sounds good? Yeah. But it's not going to make a huge difference, so it should be okay. So even you can also put the number as plus or minus 2.58. That's okay. It's not going to make a huge difference. Okay to use. All right, anybody has any other question? If you're all good, then I can see you tomorrow and I can talk more about that. But go over everything, just get comfortable using your TI and make sure you understood how to get the lower limit and the upper limit using here. Bye-bye. See you tomorrow.
Thanks so much for your help, Miss Paula.
Thank you.
Thank you. Bye.
Thanks.
Bye.
Bye bye. Thank you.